Hi guys, today we'll be discussing indices, surds and logarithms. This is topic 3 in a complete series of advanced videos. So let's get started. Let's dive into it straight away. So indices, surds and logarithms. This chapter comes in 3 different parts and we will address each different part. So let's start with the laws of exponents. There are several laws you have to remember when discussing exponents and indices. So law number 1 is the multiplication. 8 to the power of m multiplied by 8 to the power of n equals 8 to the power of m plus n. So multiplication and addition are linked together when we're talking about exponents. So the m, as long as the base is the same, see the base here is a. As long as the base is the same, the exponents can be added together when the two bases are multiplied. For example, 2 to the power of 2 multiplied by 2 to the power of 4 equals 2 to the power of 2 plus 4, which is equal to 2 to the power of 6. Because the base is the same, we can afford to add the exponents. That's law number 1. So let's look at law number 2. Law number 2 is such that 8 to the power of m divided by 8 to the power of n is in its exponent form 8 to the power of m minus n. So division and subtraction are linked together when we are addressing exponents. So for example, 3 to the power of 4 over 3 to the power of 2 is equal to 3 to the power of 4 minus 2 equals 3 to the power of 2. The only condition for this law to work is that both bases are exactly the same. If they are different, this law cannot be applied. So law number 3 is the power of indices. So let's say 8 to the power of n is inside brackets, and this 8 to the power of n is done to the whole square of n. Then this equals to 8 to the power of m multiplied by n is equal to 8 to the power of mn. For example, let's say we have 4 to the power of 3 and to the whole square of 2 is equal to 4 to the power of 3 times 2, which is equal to 4 to the power of 6. Next law, these 3 laws are for same base. The same base, as long as the exponents have the same base, these laws can be applied. However, if we are dealing with the same index but not necessarily a different base, then we can apply these 2 laws. So this is law number 1 for same index. A to the power of n m times b to the power of m is equal to ab to the power of m. This pertains to law number 3 where we have exponent inside the bracket and its whole square to a different number. So 8 to the power of m, different base, a and b are different bases, but the indices are the same, denoted by m. So when 8 to the power of m is multiplied by b to the power of m, it can be represented as ab, the whole value to the power of m. The second law, when it concerns is the equal indices, is 8 to the power of n over b to the power of n. So a and b are totally different bases, but the two exponents are exactly the same. So this can be represented as a plus b, a over b whole power to the power of n. So the first 3 were for the same base, and these 2 are for the same index. But exponents and indices can get a bit more complicated than that. Let's have a look at this. There are a few more laws, but these concern negative exponents and fractions. For all the laws I'm about to state right now, the one condition it has to meet is that the base, which I'm going to denote as a, must be greater than 0. The base must be greater than 0. Only then will the following laws be applicable. Let's have a look. So law number 1. Anything to the power of 0 equals 1. This positive values. Any positive value to the power of 0 must equal 1. Number 2. 8 to the power of a negative exponent is equal to 1 over 8 to the power of that exponent in its positive form. Alternatively, 1 over 8 to the power of negative n is equal to 8 to the power of n, because we use the negative reciprocal of it. Law number 3, a to the power of 1 over p is equal to the square root of a, and that square root will be done to the power of p. So the most common example, the most common application of this is when it concerns square roots. For example, the square root of 4 is actually 4 to the power of 1 over 2. In a square root, since the square root is done to the power of 2, there's an invisible 2 over there. And this is known as a square root. When we have a cube root, and there's a value inside, this is 9 to the power of 1 over 3. This applies mainly to square roots and working with exponential fractions. Law number 4 is a bit more complex than this. It's a to the power of q over p is equal to p outside the square root, a inside, the whole thing to the power of q, or alternatively p outside, a and q inside. Same thing. So these 4 laws are applicable only when a is greater than 0. If a is not greater than 0, these laws cannot be used to solve exponential equations. Okay, let's try one example. Okay, so 3 to the power of 4 minus x is actually equal to 3 to the power of 4 multiplied by 3 to the power of negative x. Well, 3 to the power of 4 is 81, as we know. And now we have to use the law of negative exponents to solve the rest of this expression. So 3 to the power of negative x, as the law denoted just now, is actually equal to 1 over 3 to the power of x. The positive form is in the denominator because it's a negative exponent. So an 81 multiplied by 1 over 3 to the power of x is actually 81 over 3 to the power of x. See, there are no negative exponents. That's the aim of this equation. And 4 to the power of 3 over 4 over 4 to the power of 9 over 4. See, that what we have to recognize here is that it has the same base, 4 and 4. So we represent 4 as an equal base, and the exponent in the numerator and the exponent of the denominator are subtracted together to combine this into one expression. So this essentially equals 4 to the power of 3 over 4 minus 9 over 4. If we simplify 4 to the power of negative 6 over 4, negative 6 over 4 simplified is 4 to the power of negative 3 over 2. Now let's take this a step further. Let's remove the negative exponent by placing it in the denominator. Okay, and then since we do not want to leave this hanging as an exponential fraction, just to represent a different law, let's apply the condition concerning square roots. So as we said just now, let me put that law down here so we can use it here. So 8 to the power of p over q is equal to p a the whole thing to the power of q. Alternatively, the q can go inside the square root to the power of a. So let's convert 4 to the power of 3 over 2 using this condition to make it a square root. Okay, so the 2 is equal to q, so the 2 comes outside the square root, and in a square root the 2 it goes without saying, so it is an invisible number, so it's technically 3 over 2 signifies that this is a square root. So let's we don't have to put 2 outside there, and then 4 comes in as there's the base inside, and the whole thing, or inside the whole thing goes to the power of 3, or alternatively the inside can be squared. 4 to the power of 3 is 64. So this should be how you represent your answer in the end. There can be no negative exponents preferably no fractions unless stated so. Convert it to a slick and clean form before you present your answer. Let's try this question that sums up all of the above, and then we can end this topic on the laws of exponents. 2 to the power of 4, x to the power of 3, y to the power of 2, z to the power of 5 over 2 over 3 to the power of 2 x z to the power of 7 over 2. Okay, so now we have to combine the multiplication laws, the division laws, and the exponent laws. So 3 to the power of 4 divide 3 to the power of 2, same base, 4 minus 2 is 3 to the power of 2, so that comes at the top. X to the power of 3, x to the power of 1, 3 minus 1, x to the power of 2. Y to the power of 2, there's no value of y down there, so it's considered y to the power of 0. So y to the power of 2 stays the same. Z to the power of 5 over 2 divided by z to the power of 7 over 2, z to the power of negative 2 over 2. 3 to the power of 2, x to the power of 2, y to the power of 2, and z to the power of negative 1. So as I said, one condition we have to follow is that there can be no negative exponents, and 3 to the power of 2 is equal to 9, so I'll put that down straight away. 9x square y square is the same. So z, we have to take the negative reciprocal of it. Z to the power of negative 1 is actually 1 over z to the power of 1, which goes without saying. So we combine this together to have 9x square y square over z as the final answer. Now you can try out different questions to solve this, to solve exponential equations using laws. The next video will be about surds, and then we will go into logarithms and natural logarithms using the base of e, but let's treat this as an introduction video. So till next time, bye guys.